I also need to say, as someone who designs a lot of the magnets, I wouldn't describe supersymmetry as a low hanging fruit by any means.
Did I talk about? Did I? No, of course not. I mean, you have to. Well, not only the magnets, but the whole enterprise of big accelerators is extraordinary. Right. Extraordinary convergence of all kinds of insights into the world physics, ranging from magnet design to detector design with fast electronics and vast amounts of computation to analyze the results, some of which uses neural nets. But so yeah, I mean, it's our civilization's answer to the pyramids, but much better because it's
more useful than a big pyramid in our backyard.
It's driven by more laudable goals, I think, and also it's not. Well, it involves graduate students, but not slave labor as such.
But I guess my point is that with supersymmetry being so difficult, but you were also talking about how in biology and these are all ripe for the taking. Do you think there's any kind of like very ripe low hanging fruit left in physics, or do you think we're
I see what you mean by so it depends what you mean by low hanging. So there are ideas that seem very ripe, so very ripe fruit. Now, low hanging is, I guess, it depends on how big a ladder you give yourself. But what I took to be low hanging is things that we sort of know how to get to, and it's just a matter of expense or dedication. The really low hanging fruit, I guess the model is that some lone genius in a loft somewhere has a bright idea, and people say, "Oh my gosh, how did I not think of that?" And do the experiment the next day, or maybe the person does the experiment himself, or doesn't need an experiment. It's just so obviously true, and things like that can happen. I would say, something like that happened with inflation. There's a really great idea that wasn't there one day and was there the next day. And in retrospect, the basic, everything you needed was there. I regret to this day that I didn't think of it, but so it can happen. It's very difficult to anticipate because low-hanging fruit these days, with so many physicists around the world and bright people, usually doesn't go unpicked for very long. And if I knew something like that, I wouldn't be telling you. I'd be doing it, But I can tell you that there's the first category of low-hanging fruit is where a much more inclusive definition, which is at least you know how to do it. And so, the other kind of the unpredictable low-hanging fruit that might be low in the sense that a single person could grab it in one go is very difficult to know in advance. Clearly, it gets harder and harder as our sophistication increases. But even in fundamental physics, for instance, I mean, famously or infamously, string theory, which is a very serious enterprise and may well contain the ideas that will lead to a final theory, doesn't really have a formulation. It's called a theory, as if there's a theory, but it's not. It's really a grab bag of ideas that have a certain inner coherence, but I don't know what the question is to which string theory is the answer. It doesn't have anything comparable to gauge symmetry or the principles of general covariance and general relativity, or even things like chirality, or something. It doesn't have a leading principle that organize, and you can't write down what the equation is. There's no equation to which it's the solution. So maybe some bright person will figure out what the missing principle is, and then this grab bag of ideas, maybe transformed in some way, maybe added to, suddenly will become much more usable and much more predictive, and so it's conceivable, but it's been a while, and that hasn't happened, and so it can't be too easy. Well, I don't know. I mean, it's hard to tell. It's hard.